is the study guide for section 8.3. This is on tests for parallelograms. You can show that a quadrilateral is a parallelogram if you can show that one of the following is true. So it lists you the 5 ways that you could show that a figure is a parallelogram. Both pairs of opposite sides are parallel. That's your definition. Number 2 says both pairs of opposite sides are congruent. That's a theorem. Number 3 says the diagonals bisect each other. Also a theorem. Number 4 says both pairs of opposite angles are congruent. Number 5 is a pair of opposite sides is both parallel and congruent. It even works through an example. But this list is nice to reference when you're doing all of the worksheets from this section. So we're going to determine whether each quadrilateral is a parallelogram. We're going to write yes or no and give a reason for your answer. In number 1, I noticed that my top and bottom are congruent. Also, my left side and my right side are congruent. So yes, this is a parallelogram. And the reason is both pairs of opposite sides are congruent. So I'm going to write opposite sides congruent. Number 2, the figure doesn't look like a parallelogram. That doesn't mean that it's not going to be. Again, you need to reference these using the information they give you to see if it is a parallelogram. So 28-degree angle, its consecutive interior angle is 152. If you add those together, you are going to get 180. So that makes parallel segments. That doesn't mean it's a parallelogram because these certainly don't look parallel, and they need to be. And there's no way for us to tell if they are parallel because we don't have consecutive interior angles here or here. So it's really tough to say one way or the other. I'm going to say no just because they say write yes or no. And then I'll just say only one pair of opposite sides are parallel. Number 3, these two angles are consecutive interior just like these were, but these don't add up to 180. So that means these sides are not parallel. And if they're not parallel, then it's not a parallelogram. So I'll say top and bottom aren't parallel. I know that looks like a weird symbol, but the parallel mark looks like that. If you put a slash through it, it means they're not parallel. Find the values of x and y that ensure that each quadrilateral is a parallelogram. So we're not proving that it's a parallelogram, we want it to be. So if this angle is 60, we need this angle to be 60. So 5 times something needs to be 60. Just divide by 5. Y needs to be 12 for this to be a parallelogram. Now you also need to figure out what x would have to be. If this is a 60-degree angle, then this angle right here needs to be 120 degrees. Remember, your consecutive interior angles are supplementary. So 3x plus 60 equals 120. 3x will equal 60. 1x will equal 20. So both of these things have to happen for this figure to be a parallelogram. We're just using the fact that our opposite angles need to be the same, and our adjacent angles or consecutive interior angles need to be supplementary. Number 5, same deal. We want this to be a parallelogram, so what has to happen is we have to have congruent alternate interior angles. So if this angle is 24 right there, its alternate interior needs to be 24. So 2x needs to be 24. So 1x is 12. Now, same deal over here. This angle is 20. That angle needs to be 20. So x plus y needs to equal 20. Now notice how I didn't write x plus y because I know what x is at this point. X is 12. So 12 plus something gives you a 20. It would be 8.